In this video, we're going to take a look at the freshly released Laravel Pose. Pose is a package, a first-party package from Laravel that gives you feedback about your application and about your servers. So how much CPU is being used, ran, slow queries, exceptions being thrown, the jobs that are being handled, etc. It's a really cool package. Now, keep in mind, this isn't like my regular video. This is not a controlled sandbox environment where I know what I'm doing. I've actually never used Pose. I've just downloaded it. I just set it up. And I already recorded this video, by the way. I'm recording the introduction after the fact. But on this video, you'll be learning how Pose works with me. I've never used it. I don't know the internals. So bear with me. There are going to be some hiccups, but this is also how I learn things by myself. When I get my hands in a new package or when I want to understand how something works, this is what I do. This is how I dig into the internals. On this video, you're going to learn how Pose registers its metrics. That is how it records things like an exception that happened, a job that was dispatched, a logout, a slow query, or even data about your servers. How it does that? How does it hook into the Laravel lifecycle of the Laravel events? And how does it transfer that information to either Redis or to your database? So let's jump into the code. I think you're gonna like it. So this is a regular Laravel Jetstream application, and I haven't done much besides installing Laravel, installing Jetstream logged in, and installing Pose. I've also created an account so I could execute some queries, but that's pretty much it. And then after installing Pose, I logged into it, and it's pretty great. So as you can see, it's a dashboard with a lot of information. We have application usage, queues, slow queries, cache. I couldn't create any slow queries, so we won't be using this. But even this is pretty amazing. It gives a lot of information about the application. So for example, I've tested with some jobs. We can see that we had 3 process jobs and 3 queue jobs at this point. And then at this point, we have 1 queue job. So it gives you a lot of information. I'm not going to go in depth into that because that's in the documentation. I went to look at the source code, but I just played with it a little bit. Now, obviously, you should go into the documentation, and it has all the core concepts, including performance, the Redis, ingest, which is not the default, etc. But let's go back here and let's try some things. I got really interested in this stat, so let's play with it a little bit. Let me go here and run our Pose check. If we refresh this, there we go. So we can see CPU usage, memory usage, and storage. Let's close the command. As you can see, the command runs as a daemon. So the first thing I would do is look into this. Let's go into vendor and then Laravel, Pose, source. Okay, now we have all the code for the package. If we go into commands, we have the check command, which is what we were running. Take a snapshot of the current server's Pose. Okay, that's pretty cool. So let's see what it uses. It uses an instance of Pose, a cache store resolver, and a dispatcher. So it already gives us some hints of what this command will be using. Let's take a look at the code. All right, we fetch the last restart, which is a cache key. We define an interval, and we determine when the last snapshot was taken. Now, this while true makes it work as an infinite loop, as a daemon. That's why the command doesn't end. We have this infinite loop running. Now, let's see what it does. We define a variable, okay? So if 5 seconds before, because that's the interval, right? It's an interval of 5 seconds. It's less than the last snapshot. Then we sleep for half a second and then continue the loop. If the last restart, okay, we're not interested in this, last snapshot add. Okay, we update a variable that was previously defined. We dispatch an event short beat, last snapshot add. This event is probably consumed by some listeners, and we're going to figure out who those are at some point. We get a lock. We lock on a key, and then we dispatch an isolated beat. Okay, that's pretty interesting. Who consumes those? At the end, we store this information. So we make an instance of ingest. Ingest is an interface, so that already gives us a hint that we might have multiple implementations for this. We have Redis ingest and storage ingest. Okay, so Redis ingest obviously adds this to Redis. And storage ingest just forwards the call to a storage instance. And let's see what we have here. A database storage. Okay, that makes sense. If you have a storage ingest, you're going to forward that into a storage abstraction. Okay, let's see what this does. We call the ingest method on some entries that we have. Oh, that's a nice usage of lottery. So we make a lottery where if we have a winner, we're going to trim the ingest. Okay, pretty cool. That looks good. Let's take a look at how this works on the storage ingest, which is called store on a storage. In this case, it's a database storage, so it's this method. Okay, we get the entries, a collection of entries. We partition them, and then we just add a bunch of things into the database. So the post command, the check command. Okay. Now, where does this get information from the system? That's what I'm interested in. Let's see. We call store, and you have entries. Oh, this works for any type of okay, cool. Okay, so we probably have recorders. Now let's look into recorders, servers. That's what we were interested in. Okay, so we get a shared beat and we want to record something. Oh, so that's why we have those beats. We're dispatching a shared beat and the recorders consume them. So we get information about the server, like the server name, memory total, okay? And then we pass that into the post instance. So we call record on post, and that adds something into the entries array. So we have recorders which listen to shared beats. In this case, for job queued, I don't know if I have others that listen to the shared beat, but servers is one that listens to shared beats, and we dispatch those into the check command. And what they do is they get some information, and then they record that in our post instance. We set some data. That generates an entry. If we go here, you can see that we have entries, and the entries being added to this array in memory. And now at the end of this command, we call the store method on post, which uses these entries. And after using them, it flushes them, right? We call the flush method to flush the entries. And then when the command runs again, or in this case, when this loop runs again, because we have a long running command, it is going to register new entries by dispatching those beat events and then store them. Pretty interesting. This also means that we can add more context to this command without touching any code. We can just listen to this shared beat event because this is dispatched using the event dispatcher. And if we want to add new entries into post, we can do that without touching any post code. Pretty cool. Now, besides servers, I think this looks great. And just looking at the recorder specifically, it already gives us a hint of how Laravel post works. For example, if we look into queues, right, into the queues recorder, we have the same structure, but it listens to different events. It listens to events related to jobs. And Laravel is going to dispatch those. So when you queue a job, Laravel dispatches an internal event called job queued or job processing, that kind of thing. And then post is going to hook into those events, it's going to listen to them, generate some information, and then record something into post. Let's look at another one, slow queries. So we have an event called query executed. This runs every time that you run a query using either the Laravel query builder or using Eloquent, which uses the query builder behind the scenes. And it's the same thing. We fetch some information, and then we add some information into post. Now, we're passing this as a closure, right? Which means it isn't executed at the same time. I imagine that post has some place here, probably in the storage, where it actually executes each one of the, let's call them lazy records, on the store. So yeah, we execute each one of the lazy, I'm doing air quotes, executions. And then we also use the existing entries. So if we have lazy executions, the in-memory representation of entries is not updated in real time, only when this is executed. And then we can safely ingest that. All right, so we'll listen to all of this. We have those recorders. And I imagine it's the same for everything. Requests, let's take a look in exceptions. Yeah, so this hooks into the exception handler. After resolving the exception handler, so dispatcher will listen to exception reported, and then we record this exception. Now, where is record being coming from? Oh, we have a callable that's being passed into register. Okay, we'll have to see how this works. This one's trickier. All right, now that we know how the recorders work, and we know that we have different ingests and different storages, although it only ships with one. Let's take a look at the service provider. Let's see what it does. So it registers an ingest. Okay, it boots, writes routes, migration commands, listen for events. Let's try something real quick. If we don't run any commands, does it update it in real time? Let's run some requests. 11, 13. Okay. So let's take a look at pose. Should record. Okay. So I know that we're using recorders, right, to add information into pose, but when does it actually call the store method? This is what I'm not quite understanding. We're not running any commands. So this is done within the lifecycle. Well, let's see. Cache interactions, queue servers. Let's do a quick find and see where does it call store? Okay, so it listens to some events, worker stopping, and then it calls store. Logout. I don't know what a logout is though. What is a logout event? Oh, okay. When there is a logged out. Remember user. What is a looping event? Worker stopping. Okay. HTTP kernel, console kernel. Okay, I think I know what's happening. So let's do a test. I'm going to comment this. Yes, I want to comment this. And I'm going to refresh this page. And yeah, it doesn't update it. So what Laravel post is doing, let's re-add this, refresh and rerun this, is it uses the same implementation for everything. It just calls the store method in different places depending on the life cycle. So if we're talking about the check command, like we have right here, it calls store at the end of the command, at the end of the loop, right? And this loop's going to keep running. So what it does is it dispatches this event and the isolated read as well. We have some recorders listening to it. For example, the server's recorder, and it adds information into this existing post instance. And by the time we're done with that, we just store everything. Now, this is perfect if you have a long-running command running because you can just call store. But if you're talking about a regular request, you don't have that running. So you have to call that within the framework's lifecycle. And this is what it does. We do some things when it's the HTTP kernel. That is when we're talking about a request context. So when the request lifecycle is longer than, and we pass -1, probably to ignore and just run it every time. And then we instantiate pose and we store this. This is probably singleton as well. Let's see how it is instantiated later. Now, when it's a console kernel context, we're not talking about a regular request context. It does the same thing. As soon as you close it, it calls pose store. And the same thing goes to queue workers. So in a queue worker, you have the worker stopping event, which is probably dispatched when you queue a worker. And you also have the looping event, which, to be honest, I don't know where it is used exactly, but I imagine it is used when a worker is done with a job and is going to pick a new job. So it is looping. It probably dispatches the command, and it does the same thing. It also calls store. And the same thing when you happen to log out. It also calls remember user, which I'm not sure what it does right now. Probably uses for something. Do we have something here? Maybe it's related to application usage. I don't know. This is pretty interesting. And then we also have some things for Octane. So Laravel runs slightly different on Octane. It doesn't behave like a regular PHP FPM application where each request is handled by an independent process. You have a single worker, a single process handling many requests, and that's why it has to listen to different events the Laravel dispatches during the life cycle to correctly store those post events. We're not going to talk about Octane now. And okay, so like I said, post is probably singleton. I'm not sure, but let's take a look. Where do we register this? Yeah, it's a singleton. So anytime that we inject posts, like Laravel does in its internal pieces inside posts, we're talking about the same instance, and that's why we can add stuff into the what do we call them into the entries collection in memory, and then call the store method and have them saved. So that's kind of how post works. You have either events being dispatched, but at the end of the day, you have those recorders listening to something, right? And adding entries to this post, let's call this collector. And once a life cycle ends, so if we're talking about a queue context, we're talking about either a looping event or work stopping. If we're talking about an HTTP context, we're talking about the end of the request life cycle. And if we're talking about a console kernel, same thing, the end of the life cycle. At some point, post is going to call this. If we're talking about a chat command, we're talking about the end of this loop. So this command keeps running indefinitely, and every time it finishes, before it restarts, it calls post store. That's how post stores its data. So by the time that this method is called, you could have hundreds, thousands of entries. Well, unlikely to have thousands, but you could have a lot of entries. And now it's the package's job to ingest those. And that's where it calls the ingest method right here. And we get all of the entries, we filter which ones we should record, which depends on your settings for posts. And then we ingest all of that. Like the documentation says, you could have a storage and a Redis ingest. If you choose to use a Redis ingest, the data doesn't go straight into the database. You have to run another command to fetch the data from Redis and pass it to your database. And that's the work command. So looks a lot like the chat command. We have an ingest, okay? And in this case, we're probably expecting a Redis ingest. We have a storage. We only have one storage, which maybe the user has a different one. And you have a cache store resolver. So we fetch less pretty much like the work command, the chat command, sorry. And then what do? So we have a storage, which right now is an instance of database storage. What does it do? Let's see what does it do at the Redis ingest. So we pass a collection of items to this. Oh, no, we're looking at the store method. Okay, my bad. So we pass in storage instance. It collects the entries on Redis. If we don't have any entries, it just returns 0. Total is going to be 0. And then we call the storage. So we map through each one of these entries. We unserialize them because they are serialized in Redis. We add them to the storage, in this case, the database by default. And then we remove them from Redis. So pretty interesting. We're just passing information from Redis to the database. All right, what else do we have that's interesting here? I don't know what this restart command is. Oh, okay, it just restarts the command. So it changes something in the cache that's used by both commands. Right here, the last restart. Okay, and then we have the purge command, which I don't even know what this does. Yeah, it just calls storage purge. We just remove some data. Yeah, so I think that's a good gist of how post works internally. And I know this is not a professional video. This is how I check things. That's how I look at things from the internal perspective. What's interesting here is, I think the gist of it is we have recorders like these. We have slow job servers. They're all listening to something. It could be, it's usually an event, but they might also be, for example, let's take a look at exceptions. They also can be adding a callback to the container. So what this is saying is, after the container resolves this exception handler class, it is going to execute this, right? After the container resolves this dispatcher class, it is going to execute this callback. In this case, it is just telling the dispatcher to listen to an exception reported event. And when that happens, it is going to call this record closure. So all of those recorders are somehow listening to some events that happen within the framework. Slow queries is listening to query executions, slow jobs is listening to different job events, etc. And when they listen to something, they fetch the information and they always add it to this post instance, which is a singleton. So they all share the same instance. And they either add it lazily, so it's not evaluated immediately, or they added it synchronously. So they're recording something. This goes into a property called entries or lazy. This needs to be evaluated at some point, but it goes into one of those. And at the end of the day, Laravel is now going to call the store method. Let's see if we can find it. The store method, which takes all of those, either they're lazily evaluated, it evaluates them here. It takes all of the entries, sorry, that sounded confusing. It evaluates all of the lazy entries. Those get added into the in-memory property as well, and then it ingests all of the entries. So this is the point where data gets either into Redis or into your database. Then it also has the string lottery. So depending on whether this turns out to be true or false, it will trim the ingest. That's a configuration thing. So pretty cool, pretty interesting. That's how it works internally. And then for the check command, same thing. It's just a different lifecycle. You have this command running, but it still adds things into the property. This is through the server's recorder, for example, and then it calls store. So if you were to listen to this shared read event within your application, you could also add new things you could add your own recorder, for example, that listens to this event, and you could do something with it. You could save some information into Pose, and then the command would call this and it would get saved. Now, it also has the Livewire piece. We're not going to go into this one, but this is what they use to show this nice UI. We might go into that in another video, and maybe we could even go into the storage and the ingest classes. I think that would be cool. But I think for starters, that's a good introduction to how Pose works internally. And in fact, this is just me discovering how it works with you guys. So let me know what you think of this, and I'll see you guys on the next video. Bye-bye.